Hello everyone. This video is on the Knewton Alta assignment for section 4.4 part 2 called the slope formula. So in this video I'm going to be going over a preview version of this assignment. So please understand that the questions I see in this video may not be the same questions that you see when you work on the assignment yourself. But the objectives are the same and the structure is similar. So I'm hoping that watching me do these here helps you in some way when you work on the assignment on your own. Alright, so on the assignment page you should be seeing the title, the mastery bar that tells you how far along you've gotten, the objectives. It looks like there are 2 objectives. Under the current objective there should be a question related to that objective, and then at the bottom of every question you should be seeing a feedback button where you can send feedback to Knewton if you wish. You will not have an instructor cheat button, that's for instructors only. But you will have a more instruction button. If you're struggling with a topic or a question, click on this and you'll be taken to a page with some reading or videos to study. And then you'll be given questions related to that instruction, and completing those questions is another way to progress through the assignment. Alright, so the first objective I'm looking at is graph a line given a point and the slope of that line. Now I've already discussed this assignment here is called the slope formula. I have already discussed the slope formula in section 4.4 part 1. In fact, here's the page I wrote out. This was from section 4.4 part 1, talking about how the slope of a line is a number that indicates how steep the line is and the direction the line is going. And the slope was calculated as the rise divided by the run. If you travel from one point to another point on the line, you need 2 points to be able to calculate slope. Travel from one point to another point going up and down and left and right. How far you went up or down is the rise, and how far you go to the right or left is the run. And then I talk about over here, right? If you go up, that's a positive quantity, a positive rise. If you go down, that's a negative rise. However many units you went down, it should be a negative value. And then for the run, if you move to the right, that's a positive change, a positive run. And if you move to the left, that's a negative change or a negative run. And then what I have here in this bubble, this cloud here, is the slope formula that they're talking about in this section. If I label the 2 points, have coordinates x1, y1 and x2, y2, then the rise is just the change in the y coordinates, y2 minus y1, divided by, and then the run is the change in the x coordinates in the same order. So if you do y2 minus y1, right, you have to do x2 minus x1. Now you could switch these around. You could do y1 minus y2 for the rise, but then you would have to do x1 minus x2 for the run. Just make sure you're taking those differences in the same order. Alright, so again, I did all this in the last video in section 4.4 part 1. Now they're asking us to, we're given a point on a line and the slope of the line, and we're asked to make a graph. Alright, so I'll pull another page up. So the question I'm given first is, there's a point on the line, and the point we're given is negative 5, 1. Alright, so I'll plot this. X, Y, negative 5 on the X, positive 1 on the Y. And here's that point. Right, this point is on the line. Great. Right, and then they tell us the slope which I mentioned this last video, the slope is very often represented by lowercase m. Alright, and the slope is negative 5/6. So remember, you think of this as a fraction, it is a fraction, but the numerator of this fraction I'll call the rise, the denominator the run. So the rise, I'll call negative 5. That just means if I want to move from one point to another on this line, I can start off by going down 5. Alright, so from here I go down 5 units. So from y equals 1 to y equals negative 4. Alright, just subtract 5 from the y coordinate. So I go down 5 units, and then the run is positive 6. Right? Again, a positive run means I'm moving to the right. So I move to the right 6 units. So from the point on the line, not from the origin. Too many people make the mistake of going from the origin automatically. You have to start from a point that's actually on the line. So down 5, and then I move to the right 6 units. So that would add 6 to the x-coordinate, and I'd end up at positive 1. Negative 5 plus 6 is positive 1. And then I would be landing right here. So down, from the point on my line, negative 5, 1, I go down 5, that's the rise, negative 5, and then right 6. And I end up at the point 1, comma, negative 4. Right? So again, I just added 6 to the x-coordinate, subtracted 5 from the y-coordinate. I got 1, negative 4. And there we go. And that's all we need, right? All we need to graph a line is 2 points. Right? And then I can draw the rest of the line in through those 2 points. But yeah, but that's what slope indicates. That's what slope indicates. How to travel basically from one point on the line to another. And we could keep doing this. You can keep going down 5, right 6, down 5, right 6. Or you could go up 5, left 6, up 5, left 6, as long as you stay on this direction, as long as you stay on this line. And it doesn't have to be 5 and 6 either. I could also do this. Right? This is a little more, I wouldn't recommend this, but if I go to the right just 1 unit, if I went to the right 1 unit, if the run was 1, the rise would have to be negative 5/6. So I go down 5/6. So right 1 and then down 5/6, and there I'd be at this point, which would be negative 4 for x, and then 1/6 for y. I mean, this would also be on the graph, but I don't want to deal with fractions too often. But that's another way you could interpret slope. Slope just tells you how far up or down you're going to go if you move to the right 1 unit. All right, but I'm not going to do all that much. All right. All right, so back on the assignment, we're moving some points. All right, so one of these points is going to be at negative 5, 1. And then this other point, again, I can move this other point right to that point there and then move it. Go down 5, 4, 5, and then right 6. And there we are at 1, negative 4. Right? And you can even click on the points just to make sure they're in the correct positions. And you could do the slope formula, take, negative 4 minus 1 for the rise, that's negative 5, and then 1 minus negative 5 is 1 plus 5, that's 6. So you have a slope of negative 5/6 when you do the slope formula. So this works. And then after you submit your answers, you'll be told if you're correct or incorrect. And then you'll be given some sort of answer explanation. Please read through the answer explanations. Right, just to make sure that you understand why something's correct or incorrect, and hopefully you can learn from your mistakes for future questions. Alright, so next question. Alright, so this is the same objective, graph a line given a point and the slope. Alright, so once again I'll write this one out, and then after this I'll probably stop drawing them. So we know that the point 1, 2 is on the line. The line passes through the point 1, 2 and has a slope of negative 1/3. So a point on the line is the point 1, 2. So I'll plot that. Again, if you have graph paper, it'll probably make this a little easier to look at. But 1 on the x, 2 on the y. So here's the point 1, 2. Right, this point's on the graph of the line. And then we're told that the slope is negative 1/3, right? So the rise I'll call negative 1, right, the numerator, and then the run positive 3. And remember, a negative rise means move down. A positive run means move right. So I go down 1, and then right 3. 1, 2, 3. And I land at this point here. Alright, there's down 1 unit, right 3 units, and this point is the point 4, 1. Right, so 1, 2's on the graph, 4, 1's on the graph, and then we can draw the rest of the line in through those 2 points. Right, you only need 2 points to indicate a line, determine a line. And there we go. Right, there's the line we're asked to draw. And again, you can double check, do the slope formula. Slope equals take, say, 1 minus 2 for the numerator, the change in the y coordinates, and then do the change in the x coordinates in the same order, 4 minus 1. This is negative 1/3, right, like they told us. So that checks out. This is a good graph of that line. So again, one of these points I'll move to 1, 2, and the other one to 4, 1. Right. There, and then make sure that they're at the right spots. And again, we could keep going like this. I can go down 1, right 3, see how I'm on the line again. Or up 1, left 3, up 1, left 3, up 1, left 3, see how I'm on the line again. Up 1, left 3, I'm on the line again. Up 1, left 3, I'm on the line again. All right, the slope is an indicator of how to travel on the line. Okay, great. Right, now the next question is on the other objective. Is use the slope formula to find the slope of a line between 2 points. So again, it's just that change in y divided by change in x, right? Rise over run. So I'm just going to write this out and not even graph it. You can graph them. See a picture. Maybe I will. Just for this first example in this objective. So the points on this line are, negative 3, let's say negative 3 on the x-axis is here, and negative 6 on the y-axis. So there's 1 point, right? Negative 3, negative 6. And then the other point, 0, 3. So 0 on the x, 3 on the y. That would be a y-intercept. Right? And then here's the line we're talking about. All right, something like that. Now notice, this is going up as you go to the right. So this should have a positive slope, right? Again, I discussed this in section 4.4, part 1. Right? If the line's going up to the right, it has a positive slope. If it's going down to the right, it has a negative slope, as we've seen. If it's horizontal, it has a slope of 0, and if it's vertical, it has an undefined slope, right? All that stuff was discussed in 4.4, part 1. But yeah, so, again, there's negative 3, negative 6, and 0, 3 are the points. Just call these, x1, y1, x2, y2. The slope is the change in the y coordinates, so 3 minus negative 6 in the numerator, divided by, and then the change in the x coordinates in the same order. Since I did 3 minus negative 6, I have to do 0 minus negative 3 in the denominator for the run. Now 3 minus negative 6 is 3 plus 6, that's 9. 0 minus negative 3 is 0 plus 3, that's 3. And 9 divided by 3 simplifies to just 3 over 1, or just 3, right? you should be simplifying these as far as possible. So the slope is 3. Easy enough. And again, it should have been a positive number based on the look of the line. But they have slope equals. I just had to put the number 3. Okay. All right. One more of these with the slope formula. So now this time I'm not going to even draw a line. I'm just going to write these points down, and we'll use the formula. So they're telling us the point, -2, -9 is on the line, and so is the point 1, -4. So remember, the slope is just the change in the y coordinates. So say I always do second minus first, right? -4 minus -9. Right? And then take the difference in the x coordinates, 1 minus -2, take them in the same order as you took the difference in the y coordinates. Now -4 minus -9 is -4 plus 9, that's positive 5. And then 1 minus -2 is 1 plus 2, that's positive 3, and that's as simple as that gets. So the slope of this line is, 5/3. It's positive, so if you were to graph the line through these points, it should be going up as you go to the right. But all they want is the slope, though. All right, 5/3. Rise over run. Change in y over change in x. All right, and then the rest of these I don't think I need to go back to paper for. I've done a couple of them on paper for each of them. So this one, if I do change in y, 0 minus 4 is -4. And then the change in x goes in the denominator. -5 minus 1 is -6. -4 divided by -6 would be positive 4/6, but 4/6 reduces to 2/3. So the slope of the line going through these 2 points here is positive 2/3. Hooray. And then one more of these. So again, I like to do the second minus the first, the way they're given to me. So -10 minus -1 would be -10 plus 1, which is -9. So the numerator, the rise, is -9, and the denominator, the run, is the change in the x coordinates, -9 minus 4. -9 minus 4 is -13. So I have -9 in the numerator, -13 in the denominator, and negative divided by negative is positive, so this ends up being positive 9/13 for the slope. Positive 9/13. And if you were to graph the line going through these 2 points, it would be a line that goes up as you go to the right. It has a positive slope. Great. So those should be pretty quick if you know the formula. It's a pretty simple formula in my opinion. Alright, then back to the graphing. So again, we're using slope here. So -6, 1 is on the graph, so I'm going to move one of these points to -6, 1. And I'll move the other point there as well. Alright, so we don't have a line yet. And then the slope is -6. Now if there's no denominator, technically there's a denominator of positive 1. So I'll say the rise is -6 and the run is positive 1. So I'm going to go from this point down 6 and then to the right 1. And there you go. And here's 2 points, -6, 1 and -5, -5. And you can calculate the slope. Make sure that, take the change in y over change in x and see that you get -6 as your slope. And you should. And I should have just one more of those based on my progress. Alright, so here -6, -1 is a point on the graph. So I'll move one of these points to -6, -1. Alright, there's -6, -1. I'll move this other point there as well. Alright, and then the slope is -4/3. So numerator -4, denominator +3. So down 4, right 3. So from this point I go down 4 units and then right 3 units. And there we go, and we land at the point -3, -5. Alright, and you can double check this. If I subtract 4 from the y coordinate, I get negative 5, and if I add 3, move right 3 to the x coordinate, I get negative 3. This works. And you can also use the slope formula with these 2 points and make sure that the slope is indeed negative 4/3. Alright, so simple enough, I feel. I hope you feel the same way. And that should be it for this preview version of this assignment. Now, like I said at the top of the video, right, the questions I see here are not going to be the same questions that you see, but the objectives are the same, the structure should be similar. So I'm hoping that watching me do these here helps you in some way when you work on the assignment yourself. And thank you very much for watching.